Oh, please.
Thank you, Thorstein. I want to focus this talk on how the warm ice from the last interglacial period, that is called NEEM, occurs in the Greenland ice cores. This warm period is particularly interesting as it is warmer than our current interglacial period and documents the Greenland climate and ice sheet response to Arctic warming. And the last two drilling in Greenland were specifically aimed at retrieving ice, undisturbed and chronologically in order, from this Eemian warm period that occurred from 130,000 to 150,000 years ago. And as you can see on the slide, I'm listed as a single author of this presentation, but of course drilling operations are not a one-man's job, but a major operation, both financially and manpower-wise. And the last project, which is called NEEM, was cooperation between 14 nations, as you can see on the slide, under the umbrella of the 2007 International Polar Year. And I'm, of course, very proud that the Icelandic flag is there among. But more than 100 people were involved in the study of the core, and the data I will be showing here is mostly theirs. But Norway is not a partner in the Greenland deep drilling project, but however very, very active in paleoclimate reconstructions, and in fact a leading nation in retrieving paleoclimate data from the North Atlantic sediment cores. We are therefore partners in the paleoclimate community and rely on each other's fundings, and I will come to that a little bit later. But I will start just briefly. Hvað ætla ég að gera hérna? Okay, I'll just start very briefly of mentioning all the cores that have been drilled in Greenland through the years for reconstructing paleoclimate. You can see there is a little bit maybe difficulty in reading the table, but it all started with the drilling in Camp Century in West Greenland in 1962 to 1966. And then the next drilling was in South Greenland, I3, in 79 to 81. Then the two summit cores, GRIP, a European core, and GISP2, a core which the American drilled, and they are just 30 kilometers apart. And then the North GRIP, and the last core, which finished in 2010, is the NEEM core. I should mention that all the cores, they are located on the ice divide, and that is because there is the greatest possibility to get the undisturbed chronology of the ice, and also the oldest ice that is found within Greenland. And just to emphasize that this is not a one-man's job, I just want to show you some photos from the ice and to get you into the mood of the rest of the talk. These are flights to the ice with instruments and people. This is a Hercules American plane, but a lot of planes from Akureyri have been flown to the drilling sites in Greenland. And here are just some equipment. You can see that these are major operations, tents for people to live in, and this is the ice core factory under the surface of the ice, or the science trends. as we call it, below surface, where all the scientific investigations are done, and the precious ice core. So there are a lot of things that can be studied from the ice cores, and this is how the ice core is divided for physical property measurements, for investigation of gas, for chemistry, and then for isotopes. And that is the main subject of my talk here, because that is where I participate in these ice core projects. And then half of the core is just kept for future people, future studies, just kept for an archive and studies for future scientists. So I got some parts of this isotope section. Isotopes are water isotopes are interesting because they are proxy for temperature. So if we measure the isotopic composition of the ice, we can sort of estimate the past temperature at the site. Iceland has over 20 years been an active partner in the international project on paleoclimate with stable isotope measurements, and we have participated in measurements of 60 ice cores from Greenland, especially where precision is needed, as when studying the deuterium excess and diffusion of isotope, and to determination of isotopic composition of international working standard, which is of course very important, because there are many laboratories in the world that are looking at the isotopes of the cores, and we of course have to all use the same standards. I wanted to talk about the Eemian, how the Eemian ice is in the Greenland cores. It is interesting, as I said, because it's warmer than our present interglacial period, and then the findings we can read from this warm ice can be used as an analog for the future warming that is predicted for the Arctic. In all the cores, all the deep cores, some warm ice has been found towards the bottom of the cores. We thought when we were studying the grip core, one of the summit cores, that we had found the Eemian circled on the slides, and we even got a Nature paper out to discuss the Eemian, and thought that and we found that there was a lot of change in the climate during the warm Eemian period, as you can see on that. But when the Americans finished their core a year later, we saw that there was a very much difference in the records, in the two records. So the stratigraphy in neither of the cores was undisturbed. So we got these signals, they are not representing the climate. So then the search for an undisturbed Eemian was then started. And as I've said, the Eemian is very important, as it was warmer than our current interglacial, and documents the Greenland climate and ice sheet response to Arctic warming. Studies of Eemian climate and the evolution of the Greenland ice sheet during this period is valuable as an analog to the expected future warming. And the first drilling after the summit course, specifically to get ice from this important period, was the NGRIP drilling, about 320 kilometers northwest of the summit course. And but very successful in getting the ice from there. This is an isotopic profile of the grid, which is the summit core we had before, and the north grid core. And we can see all the changes during the last interglacial period we see in both cores, but it turned out that the north grid core did only give us information, or did only have ice that were 123,000 years old. So it just gave us a glimpse into the Eemian period, but not the whole period, as you see with the red profile. And that is because there was the bottom or at the drill site was very warm, and there was a melting from the bottom. So the ice, the oldest ice, had all gone away from that drill site. But because of the melting, the layers that was in the ice core are very thick, or the annual layers are much thicker than in previous ice cores, and the stratigraphy is undisturbed. So we got a very good profile to study all the abrupt changes we see in the ice core, but we didn't get the Eemian apart from the last part of the Eemian and into the last glaciation. And just to say a few words about the importance of the North Grid core, even though it didn't contain the whole Eemian record, is that because of the melting at the bottom, it is very well suited to study the very rapid changes we see in the cores, and we can see that they happen in only a few years. We can see, for example, I don't know why this Eemian is there, it shouldn't be, but we just ignore that from this, but we can see that the changes from the last glaciation to our present interglacial period, some 11,700 years ago, occurred very quickly. Here you see different parameters. The small d stands for deuterium excess, and it represents situations in the source area. And you can see that these parameters, it changed over only 3 years, from the cool glacial period to relatively warm periods. The isotopes, the blue trace, it happens in which is representing temperature. The temperature change happened in about 50 years. And then the dust in the ice, the glacial ice has a lot of dust in. The interglacial ice has very little dust in. So in about 50 years, the dust load decreases. So you can see it's on the green profile shows the annual precipitation, and it shows how quickly it increased while when we got the warmer climate. So this is just to emphasize that the North Grid core, even though it didn't give us the Eemian, it gave us a very good information about the rapidity of the climate changes. So we have the North Grid and the Greenland Eem comparison here. Greenland is a very small ice cap just off Scoresbysund. I just want to show you the locations better. It's a very nice small ice cap. It's not one of the deep ice cores from the Greenland ice sheet. It's a small ice cap. It's only 325 meters deep, but it contains the whole record and presumably the Eemian as well, according at least it's very similar to the NGRIP record. So after the North Grip, the second attempt to get an Eemian ice from Greenland was done in 2005 to 2010 at a site called NEEM, North Eam. And this drilling was done under the umbrella of the 2007 International Polar Year. So here is the NEEM isotope record, and you can see, I hope, all the familiar changes, the isotopic changes on the uppermost panel, all the very rapid climate changes during the interglacial period, but around 2,200 meter depth, something happens within the profile, very abrupt changes that are obviously not related to changes in climate. These are some disturbance in the stratigraphy. We can see that on the rapidity of the changes. And this occurs about 2,200 meters depth. However, we can see around 2,400 meters that there is a period, a stable period, which looks or seems to be okay and may represent the Eemian ice. And here we see the more clearly the NGRIP and the NEEM profile, all the familiar figures during the last interglacial, and then this mysterious isotopic profile from about 2,200 meters. So something is wrong, and we didn't succeed in getting the stratigraphy of the NEEM ice either at this NEEM location. But now comes to the Norwegian part of this paleoclimate study. I want to just refer to a paper that was published in 2010 about sediment cores in the theme, especially this MD 99-2289 that was studied by a team from Bergen. And you can see they studied some different parameters in the sediment cores. The topmost profile is an isotopic profile of foraminiferas that's found in the sediments, and you can see that around 120,000 years ago there is a change in the isotopic composition towards a warmer climate. So the Eemian is represented in the sediment cores, and I want especially to draw your attention to the lowest profile, the calcium concentration. There, the resolution of the sediment studies are very high. It's a continuous measurement, and you can see in comparison the North Grip Delta 018 profile is shown just on top of it, and you can see how the comparison is good between the climate parameters we have in the Greenland ice and the climate parameters we have in the sediment cores in the North Atlantic. And you can see that they have a very well-defined Eemian in the calcium concentration, which reflects the productivity of the sea. Also, another core from people from Kiel has also been looking at the sediment cores, and here we see a comparison between the NEEM or the isotopic profile in the NEEM core and isotopic profile within the sediment core shown in red, and we can see that probably a major part of the Eemian ice within the NEEM core is okay, but we have some disturbances as well. So people started to look very carefully into these ice and do a lot of studies on the ice that seem to be disrupted. The stratigraphy is not straight. So, and I want to show you that here, what people have been doing and trying to figure out or reconstruct the climate profiles from this NEEM data. And here you see some of the parameters that have been measured within the ice at this depth interval, and to get it more easy to explain and discuss, the intervals have been color-coded, and you can see that there is discontinuities in all the data measured, both the isotopic composition of the ice, the methane composition, the delta O18 in the air bubbles, and both the delta O18 in the air bubbles within the ice and the methane concentration, they are the same wherever you are. So they should be the same in Greenland and in Antarctic ice. So we can compare what we see in Greenland to well-studied cores, for example, in Antarctica, to compare. But these are the data in light gray to the left of the figure, around 2,200 meters. The North Grid profile is shown, and we can see, and we think that is the correct climate data. The North Grid is telling us down to 2,200 meters, but you can see that the parameters within the NEEM core is quite different. One thing that is very interesting to see, that the highest delta O18 values shown on the topmost diagram with red. This is the most most part of the Eemian. And you can see, and this is the warmest part, and you can see that the methane and the N2O concentration within the ice at that interval varies a lot, and this suggests that this has been a surface melting on the ice. So it has been very warm. It just continues. So this is what people have been studying and trying to reconstruct the profile. And now I want to show you the reconstructed file. This is really from a paper that's going to be published very shortly in Nature by Dorthe Jensen and all the people that have been cooperated in the NEEM community. And here is a reconstructed profile of the NEEM record. And we can see in light gray the North Grid to about 115 on the 8th scale at the bottom, and in dark gray is a Dronning-Maudland record, or that is a core from Antarctica. And lot of these parameters, as I said, are globally homogeneous, so they should be the same in Greenland and in Antarctica. And when these reconstructions have been done using the globally homogeneous parameters and the Greenland core, then this is how it looked like. It is on this slide, it is shown that the first zone, that is light blue in color, was folded. There is no ice from about 108 meters to about 115 meters in the NEEM core because of folding. The zones blue or yellow and green, they cover the same period and they were reversed in the core, but the red interval was the warmest part of the Eemian and covers most part of the Eemian, as you can see. So this is really the record reconstructed profile for the Eemian, and we can or the Eemian period, and we can see that around 126,000 years ago, it started with a warm, and then the temperature declined. I want to show it better on this figure. You can see that how the intervals have been sort of fitted to the internationally or the world homogeneous data. I want to show you some radar profiles. This is a NASA data. They did some studies on the ice at the NEEM site, and we can see that the ice is seems to be or the layering of the ice is okay down to about 2,200 meters, but after that the layers become fuzzy and even folded, and that is exactly where the interglacial ice and the glacial ice meets. And the interesting thing is that the ice, the glacial ice, is very much different. It's much softer than the warm interglacial ice, and you can see on this. You can see on the mark D on this that we have very small crystals within the glacial ice, 1.5 millimeter ice crystals, and they are very well oriented, as you see on the C figure there. The C axis of the crystal are all oriented in the same direction. The last or the third figure on the D represents ice crystal from the Eemian, the warm, and there the ice crystals is about 25 millimeters, and the orientation is bad. And therefore, where these two ice types meet, they get folded. As you can see, there's a cartoon on the E part of the figure. They get folded, and the stratigraphy get disturbed. And that is really what has been found within the Greenland core, that just before the Eemian, the ice starts to get, or the stratigraphy of the ice starts to get bad. And here is some figures. Here is just at the end, I just want to show this. This is again from Thorstadal Jensen from the paper that's going to be published in Nature shortly. And you see the temperature calculations or estimation from the data I've just shown you. There is these data suggest that the temperature at that time has been about 8 plus minus 4 degrees higher than at present, and then the highest temperature was at the start of the Eemian, and then it slowly declined. On the B, you can see there was very hot, so hot that there was a surface melting at this location in Greenland at that time, and the surface elevation is thought to have first, at the beginning, been about 200 meters higher than at present, but then declined, and we got about 130 meters below present. I just want to end by showing this figure that we seem to be approaching the same climate as at the Eemian, where we had these mesh layers, and we can see this is from last summer at the NEEM site, and there is starting to show mesh layers, and the ice is so warm now at this site it is starting to melt. And I think I'll just stop here and thank you for your attention.
Yes, thank you, Árny.